Have you ever stopped to wonder where the internet actually lives? It's easy to think of the internet as something floating in the air, invisible and weightless, but in reality, it has a physical home. The internet is powered by massive, power-hungry data centers, giant warehouses filled with thousands upon thousands of computers, all working around the clock. Every photo you upload, every video you stream, every email you send or receive, they all travel through these enormous buildings where they're stored, processed, and delivered back to you in milliseconds. But there's a catch. These digital hearts of the internet have a huge appetite for electricity. It's not just about powering the computers themselves, but also about keeping them from overheating, which is a constant battle. Imagine millions of supercomputers, all running non-stop, packed tightly together in rows. The heat they generate is staggering, enough to make these rooms feel like industrial ovens. To keep things cool, data centers rely on enormous air conditioning systems and powerful fans. These cooling systems are energy hogs, often using as much electricity as the computers themselves, and driving up the total energy bill. As our digital lives expand, more streaming, more cloud storage, more connected devices, the demand for data centers keeps growing. Their carbon footprint is now so large, it rivals that of the entire airline industry, contributing significantly to global emissions. Clearly, the world needs a greener, more sustainable way to power the internet. Renewable energy sources like wind and solar are helping, but the challenge is urgent and growing every day. What if we could tap into a natural, abundant source of cooling, like the ocean itself? The idea might sound futuristic, but it could be a game changer. This isn't just science fiction. Underwater data centers are being tested right now, using the cold ocean water to cool servers efficiently and dramatically reduce energy use. China is leading the way in this revolutionary experiment, sinking entire data centers to the ocean floor in a bold attempt to solve the internet's energy crisis. Could this underwater approach be the breakthrough that changes everything about how we power the internet? The answer might be closer than you think. So, what is a data center? Think of it as a fortress of powerful computers, servers, storing and delivering the world's data. Every time you stream, shop, or share online, you're tapping into these digital hubs. They're the backbone of our connected lives, supporting everything from social media to financial markets. Data centers are built for reliability, with backup power, high-speed internet, and tight security. Without them, the internet as we know it wouldn't exist. But packing so much tech into one place creates a massive heat problem. Traditional centers fight this with energy-guzzling cooling systems, often using huge amounts of water. As our need for data grows, so does the challenge of making these centers efficient and sustainable. The race is on to find smarter solutions, and that's where the ocean comes in. Facing the energy crisis, Chinese engineers asked, why battle heat on land when the ocean is a natural cold heat sink? Enter underwater data centers, sealed, waterproof modules packed with servers and sunk to the seabed. Off Hainan's coast, China has deployed these giant cylinders, each filled with servers and designed to run for years underwater. Fiber optic and power cables connect them to shore, making them part of the global internet. The cold seawater naturally cools the servers, slashing the need for traditional air conditioning. This approach saves energy, frees up valuable land, and boosts security. The deep sea's stable environment can even extend the life of the electronics inside. It's a radical rethink of where and how we power the internet, and it's already making waves. Let's dive into the fascinating world of underwater data centers and see how they actually work, step by step. Each underwater data center module is essentially a robust, pressurized steel vessel. Inside, the air is replaced with dry nitrogen, which is crucial for two reasons. It prevents corrosion of sensitive electronics and eliminates the risk of fire, creating a safe and stable environment for the servers. After being carefully sealed, these modules are transported and gently lowered to the ocean floor, sometimes hundreds of feet below the surface. Inside, rows of high-performance servers are stacked, ready to process and store massive amounts of data. As these servers operate, they naturally generate a significant amount of heat. Instead of relying on traditional cooling systems like fans or air conditioners, the heat produced by the servers is transferred directly to the vessel's outer walls. The surrounding cold ocean water acts as a natural coolant, efficiently absorbing the heat and keeping the servers at optimal temperatures, all without moving parts or extra energy. A single durable subsea cable connects the module to the shore, delivering both power and high-speed data. This cable also allows engineers on land to monitor and manage the entire data center remotely, ensuring smooth operation from afar. If a server inside the module fails, built-in redundancy systems automatically shift the workload to other servers, maintaining uninterrupted service. This self-healing capability is essential for reliability, especially since physical access is limited. These underwater modules are engineered to operate continuously for up to 25 years without ever being opened, thanks to their sealed, low-maintenance design. The result is a set-it-and-forget-it system, highly efficient, requiring minimal human intervention, and designed for long-term operation. The ocean itself provides the cooling, while skilled engineers keep a close eye on performance and health from land-based control centers, using advanced monitoring tools. This approach is a seamless blend of cutting-edge technology and the natural cooling power of the ocean, showcasing innovative engineering at its best. Underwater data centers could revolutionize the future of digital infrastructure, offering sustainable, scalable, and resilient solutions for our ever-growing data needs. Let's compare traditional land data centers versus their underwater cousins. Land centers are massive, noisy, and require complex, energy-hungry cooling systems, sometimes using millions of gallons of water daily. Construction takes years and eats up valuable land. Underwater centers? No giant buildings, no roaring fans, just silent modules cooled by the ocean. They're factory-built, quickly deployed, and use zero fresh water. Placing them offshore frees up land and brings data closer to coastal cities, reducing internet lag. The result: faster streaming, quicker downloads, and a smaller environmental footprint. Underwater data centers are more sustainable, especially in water-scarce regions. They're a win for energy, land, and performance. The difference is night and day. As demand for data grows, this new model could become the standard. The ocean isn't just a backdrop, it's a game changer, and the benefits are just beginning. The energy savings from underwater data centers are nothing short of revolutionary. By harnessing the natural cooling power of the ocean, these facilities are setting new standards for efficiency in the tech world. Traditional data centers, which are often massive buildings filled with servers, rely heavily on air conditioning and mechanical cooling systems. These systems consume huge amounts of electricity just to keep the servers from overheating. As a result, their power usage effectiveness, or PUE, typically ranges from 1.4 to 1.6. That means for every unit of energy used for computing, nearly half as much is wasted on cooling and overhead. In stark contrast, China's groundbreaking underwater data center in Hainan boasts a PUE of just 1.07. This means that almost every bit of energy consumed is used directly for computing tasks, with minimal waste. It's a remarkable leap forward in energy efficiency. This dramatic improvement is possible because the ocean itself acts as a massive passive cooling system. The cold water naturally absorbs heat from the servers, eliminating the need for energy-hungry air conditioning units. Thanks to this innovative approach, the Hainan project is projected to save an astonishing 122 million kilowatt-hours of electricity every single year. To put that in perspective, that's enough energy to power 160,000 average homes annually. A truly impressive achievement. The environmental benefits don't stop there. By slashing energy consumption, the project will also reduce carbon emissions by 105,000 tons each year. That's the same as taking 22,000 cars off the road, making a significant contribution to fighting climate change. Imagine if this technology were adopted on a global scale. The potential impact on worldwide energy use and carbon emissions would be absolutely massive, transforming the entire data center industry. This isn't just a minor upgrade, it's a bold blueprint for a sustainable digital future. Underwater data centers could become the foundation for greener, more responsible technology infrastructure. By leveraging the ocean's natural cooling abilities, we can support the explosive growth of the internet and digital services, all while protecting our planet from the dangers of overheating and excessive energy use. It's a rare win-win scenario where cutting-edge technology and environmental stewardship go hand in hand, paving the way for a cleaner, smarter world. The numbers truly speak for themselves, highlighting just how much progress can be made when innovation meets sustainability. With advancements like these, the future of data is looking not just brighter, but a whole lot greener. The environmental benefits go far beyond energy savings. Underwater data centers slash carbon emissions by cutting electricity use, helping fight climate change. They use zero freshwater, a huge advantage as water scarcity grows worldwide. Moving data centers offshore frees up land for homes, farms, or nature. Some projects even explore reusing waste heat to warm buildings or support aquaculture. It's a holistic approach: less energy, less water, less land, and new opportunities for sustainability. By working with nature, not against it, we can build a smarter, greener internet. The ocean isn't just a cooling system, it's a catalyst for change. This is the future of eco-friendly technology. Of course, underwater data centers face real challenges. The ocean is harsh, saltwater corrodes, pressure crushes, and perfect seals are a must. Engineers use advanced materials and coatings to protect the modules for decades. There's also the question of marine impact. Will heat from servers affect sea life? Ongoing studies aim to ensure minimal disruption, turning modules into neutral or even beneficial artificial reefs. Maintenance is tough. If something breaks, the whole module may need to be retrieved. That's why redundancy and reliability are built in from the start. Security and international regulations are evolving as more countries explore this tech. These aren't deal breakers, but they require careful planning and global cooperation. The ocean offers solutions, but demands respect and responsibility. China's underwater data centers are more than an engineering feat. They're a glimpse of a sustainable digital future. By harnessing the ocean, we can grow the internet without growing its environmental impact. Faster, more reliable connections for coastal cities, and a greener planet for everyone. This technology could cut global carbon emissions, save water, and free up land. It's proof that innovation and sustainability can go hand in hand. The journey from land to sea is just beginning, but the vision is clear. The internet's future might be cooler, faster, and a whole lot wetter, and that's a future worth diving into.